Hello everyone, I'm Santanu Pal, and today we are going to discuss about gravitation. It is a chapter from grade 11, chapter number 8. And first of all, we are going to discuss about what is gravitation, what is gravitational force, Newton's law of gravitation, and all those things we are going to cover in this particular chapter. So the topic of discussion in this lecture is what is gravitation, what is Newton's laws of gravitation, properties of gravitational force, acceleration due to gravity, gravitational potential, radiation of acceleration due to gravity with height and depth, and Kepler's law of planetary motion and escape velocity. Okay, so first of all, we are going to discuss about what is gravitation. Okay. So gravitation is a force between two masses. Okay. So Newton law of gravitation states that every particle in the universe attracts each other. So if two masses m1 and m2 are separated by a distance r, then the force of attraction between these two masses will be directly proportional to the product of the two masses and inversely proportional to the square root of distance between them. It was the law given by Newton. Okay, so force is directly proportional to the product of the two masses, and force is directly proportional to the inversely proportional to the square root of the distance between them. So here you can see from the slide that F is equal to g m1 m2 by r square. So here what is g? G is universal gravitational constant, and it will be applicable not only for earth and moon, it will be applicable in the whole universe. Wherever you want to calculate the force of gravity between two masses, then the value of g will be constant for everywhere. So what will be the value of g? G is value of g equals to 6.67 into 10 to the power minus 11 Newton meter square kg to the power minus 2, and its dimensional formula is m to the power minus 1 L cube t to the power minus 2. It is the dimensional formula for universal gravitational constant. Now, in some important points about gravitational force, you have to remember that gravitational force is central and always it is conservative in nature. And gravitational force is the weakest force. So there are two kind of forces, weak force and strong force. Gravitational force comes under the category of weak force. Why is that? Because when you are jumping, you can easily overcome the gravitational force, right? But the strong force is the nuclear force. Inside nucleus, the force of attraction or repulsion, whatever is happening inside the nucleus, that is the strongest force in the universe. And gravitational force is only applicable for heavenly bodies. What it is means, gravitational force is always act between earth, moon, this kind of heavenly bodies, sun. Okay, acceleration, gravitational force is not applicable for you and me. Suppose you and me and separated by a distance r, then the force of gravity will be too much less, because the because the universal gravitational constant will be multiplied with the equation, and that's why the gravitational force is only applicable for the heavenly bodies. Newton's third law also hold good for the gravitational law, and it is a action reaction force. Okay, and another thing you have to remember that gravitational force is always attractive in nature. Why is that? Because uh, mass cannot be negative. Okay, so gravitational force is always attractive in nature. Next one is acceleration due to gravity. So when something is falling, suppose one apple is falling from a tree, or suppose you are throwing a pebble from the rooftop, then when it is falling, it is getting accelerated by the force of gravity. This is called acceleration due to gravity. The value of g, that is acceleration due to gravity, slightly change place to place, and it is taken to be 9.8 meter per second square. Okay, and it is a vector quantity because it has a direction towards the earth. Okay, because the earth is pulling everything, so acceleration due to gravity is vector quantity, and its value is 9.8 meter per second square. Okay, now what is gravitational potential? Gravitational potential at a point in a gravitational field is equal to the work done per unit mass in bringing a very light object from infinity to that particular point. Okay, and the value of gravitational potential is W by M. W is equal to Gm, and SI unit of gravitational potential is joule per kg, and it's a scalar quantity. Okay, gravitational potential energy of any object in a particular gravitational field is is equals to the work done in bringing it from infinity to that particular point, and it is denoted by U. U equals to minus g mm by r. The negative sign indicates that gravitational potential energy always decreases with increase in distance. Now, variation of g with altitude. So actually what happened when you go up, if you are going somewhere from the surface of the earth to in a flight, then there you are going to feel that the acceleration due to gravity will decrease. Okay. So here is a calculation. To do that calculation, first of all of you know that g, small g, that is acceleration due to gravity, is equal to g m by r square, by m is the mass of the earth. Okay, so in this picture we have seen that you can see that the it is a earth, and its radius is r, and at a particular height h, the what will be the value of acceleration due to gravity. So gh, that is acceleration due to gravity at a point q, is gm divided by r plus h whole square. Okay, if we take the ratio between gh and g, then we are going to see the value of gh equals to g equal into 1 minus 2h by r. That is actually acceleration due to gravity decreases with increase in height. Okay, so how much it will decrease, that when you are going to do when we are going to do numericals, then we are going to understand about it. So what we have to remember from this slide, that the acceleration due to gravity will decrease if it increases the height. If we go up, then acceleration due to gravity will decrease. Now what about what will be the value of gravity acceleration due to gravity if you go inside the earth, that is in the depth? Okay, so that we are going to understand in my next slide. So effect of acceleration due to gravity in depth, it is also actually decreasing when we go from the surface near the inside the depth of the earth. Then also the acceleration due to gravity will decrease. So the formula for that, g equals to g dash, that means acceleration due to gravity at point B in the picture, is equals to g into 1 minus h by r. Okay, so the value of g means acceleration due to gravity becomes 0 at the center of the earth. That you have to have to remember in this particular slide. So the value of acceleration due to gravity is maximum at the surface of the earth, and it will decrease when you go up, and it will again decrease when you go down. Okay, and it will be 0 at the center. It will be 0 at the center of the earth. This is the variation of acceleration due to gravity with depth. Now, Kepler's law of planetary motion. Okay, so Kepler has given three laws. So first law is that every planet revolves around the sun. All of we know that every planet is revolving around the sun, but in an elliptical orbit, not in a circular orbit. So Kepler first law talks about every planet is revolving around the sun in an elliptical orbit, and sun is at one focus. Okay, sun is at the middle. Second one, second law of Kepler's law is that the radius vector drawn from the sun, as you can see from the picture, the radius vector drawn from the sun to the planet sweeps out equal areas and equal interval of time. That is the second law. The areal vector of the planet around the sun is constant. Okay, so that's why it is covering equal area, sweeps out equal area in equal interval of time. And last one is the third law of Kepler. It says that the square of time period of revolution of a planet around the sun is directly proportional to the cube of semi-major axis of its electrical orbit. Okay, and that is T is the time for complete the orbit, and A is the length of semi-major orbit. Then T square is directly proportional to the A cube, that is cube root of semi-major axis. So these three are the Kepler's law of planetary motion. So from the first law, what we have understood that all the planets are revolving around the sun in an elliptical orbit. Second law says that the radius vector drawn from the sun to a planet sweeps out equal areas in equal interval of time. And third law is talking about the what will be the time period for covering the whole path. So it will be t square directly proportional to the cube root of semi-major axis. So these three are Kepler's law of planetary motion, and it is applicable everywhere, not only in our solar system, but everywhere in this. Wherever there is a solar system, wherever there is a planetary system, it will hold good in every aspect. Last one is the escape velocity. So what is escape velocity? Escape velocity means the velocity needed for a body to escape Earth's gravitational pull. Okay, so whenever we send a rocket, it has to overcome the acceleration due to gravity that is pulled by the Earth's pull. It has to overcome. So what will be the velocity of what should be the velocity of a rocket when it is going? When it is going up, its velocity should be 11.2 kilometer per second. If it reaches this velocity, then only it can escape the Earth's gravitational pull. Okay, so what we have understood that the acceleration escape velocity is the velocity needed for a object to escape, that means overcome the Earth's gravitational pull. So that's all for today. This is the demo video. That's all for the demo video. Okay, thank you so much for watching.